Okay, so we're doing the calculating moments by sampling exercise. This is part of week 4 expectation and the method of moments. So if you open your REPL to this exercise, you'll find this preloaded code. You are given 3 sums that are all set to 0. I suspect that we will be using these to calculate the moments, calculating the rth moments using that we're going to input into these lists here, moment 1, 2, and 3. And you're also given this variable here, myVar, which is set to an instance of a uniform random variable between 0 and 1, which we're going to use to as our x sub I here. Okay, so the point of this exercise is that we want to evaluate the rth moment for a given sample of a specific random variable. In this case, it's the uniform random variable between 0 and 1, raised to the rth power. So that's how we evaluate the rth moment, which is denoted by mu hat sub r here. Okay, so the way we're going to do that is we're going to use these predefined, pre-initialized variables here, sum 1, sum 2, and sum 3. Firstly, we're going to define our indices, so we can so instead of having indices that are from 0 all the way to 199, we want from 1 to 200. So the way we do that, because this is a loop for I in range 200, we can achieve the result that we want by writing indices index I is equal to I plus 1. That way the indices list is now populated by numbers from 1 to 200 including. Okay, so using our myVar variable here, that is an instance of uniform random variable between 0 and 1, we're going to populate our first sum, which we're going to use to calculate our first moment. So sum 1, we're going to add to that the value of myVar, and we just write myVar because this is the this myVar here represents the uniform random variable x sub I raised to the power of 1. So you just write the variable as it is. Okay. Then we're going to use that sum to calculate the first moment, which we've defined as moment 1, and make sure that you acknowledge that moment 1 is a list, and so we're going to populate the list with elements that are evaluations of the moment of the sample so far. So because this is a loop, we're going to evaluate the moment at each iteration of the loop. So in this iteration of the loop, which is the ith iteration, we're gonna say that the ith index of the moment 1 list is equal to the current sum of uniform random variables, which is sum 1, divided by indices I, which is equal to the current number of uniform random variables that we have. This is essentially representative of n here, but instead of n, it's not the entire sample, it's the sample that we have so far. It's the sample that we've reached in our series of loop iterations. So that's the first moment done. Second moment, we're going to use our sum2 variable. We're going to do a similar thing, but instead of adding just myVar, being careful that this is the second moment means that we're going to have to raise our random variable to the second power. So instead of adding myVar, we're going to add myVar squared. And then using that sum, we're gonna calculate the second moment, which we've initialized as moment 2. Again, being careful that this is a list. I'm gonna add the second moment as it is evaluated so far in the loop, which is equal to sum 2 over the number of variables that we have so far. Okay. Lastly, we're gonna do the third sum to calculate the third moment. And we're gonna add to that the value of my variable, but this time raised to the third power, because we're trying to evaluate the third moment. And then using that sum, we calculate the third moment by saying that the ith index of the moment 3 list is equal to the third sum 3, over the number of variables that we have so far. So that's all the moments calculated. We run our code to check if it generates the graph. See, when you complete this coding task, a graph should be generated. And there is a graph. Here you can see that there are different distributions that are color indicated here. It says here that the red points indicate how the first moment, which is the sample mean, changes as n increases. The blue points are for the second moment, the green points are for the third moment, and the black points are for the square of the first moment. And what this exercise actually wants you to realize is that as you feed your estimation a bigger sample size, they tend to estimate a more precise value, as indicated by the convergence of these graphs here. You can see that each of these distributions starts out very sporadic, doesn't really center around any value, but then as n increases, the number of trials of your experiment that you do, for example, increases. You tend to have a trend towards some particular value. That you tend to get more precise estimations. And that's the whole idea of this exercise. So you run your test to see if it meets the criteria. Okay, if this comes up, don't worry about it, just run your test again. It could be a networking issue. Always run your tests at least twice, sometimes more, because these tests are actually probabilistic and they depend on many more things being right than just your actual solution. So passes the test, hit submit, run the tests one final time, and it checks out.